Hello everyone. Today we will discuss about a term which relates the permittivity of free space to the permittivity of the medium. We know that if two charges are placed in air or any medium, then the force of attraction or repulsion, as the case may be, it is affected by that medium. So it depends on the medium in which the charges are placed. So let's discuss that term. That term is called as relative permittivity or dielectric constant. We know that the force between two charges Q1 and Q2 when these are placed in air or vacuum is given by so this is the magnitude which we are discussing about. So in air, so in any medium, the force will become 1 by 4 pi permittivity of the medium Q1 Q2 upon R square, right? Where epsilon naught is the permittivity of air or free space, and epsilon m is the permittivity of the medium in which the charges are placed at same distance from each other, right? Now we know, we have already mentioned this thing, that if epsilon naught and epsilon m are the permittivities of air and medium respectively, then relative permittivity, so ER here represents relative permittivity. This is given by permittivity of medium to the permittivity of air or free space, and this is also called as dielectric constant, which is denoted by K. That is, the symbol is called as kappa. So here I have mentioned this relative permittivity. This is permittivity of the medium to the permittivity of air or free space, right? So that means the value of force between two charges separated by the same distance depends on the medium in which the charges are placed. Now we can write this relative permittivity or dielectric constant in terms of the force also. So if I mark this as equation 1, this as equation 2, right? And if I am marking this as Fa and this as Fm, this is force in air and this is the force in medium between the same charges separated by the same distance, right? So if I divide equation 1 by equation 2, what will I get? I'll get force in air upon force in medium is equal to this is the formula, and this can be written as 1 by 4 pi epsilon m q1 q2 upon r square. We can check whatever can be cancelled. We can cancel it. This and this 4 pi. These will be cancelled. So what will I get? This will be 1 upon epsilon naught upon 1 upon epsilon m. And this can be written as epsilon m upon epsilon naught, which is what? This is the relative permittivity or dielectric constant. So, dielectric constant or relative permittivity this can be written as the ratio of force in air upon force in medium between the same two charges separated by the same distance, and this can also be written as the ratio of the permittivity of the medium to the permittivity of air. Just for the symmetry, I have written it air over here. So epsilon naught is epsilon air actually. So now we can mention some characteristics of Coulomb's law. So the first thing is electrostatic force may be attractive or repulsive. Second, it is Coulomb's law is inverse square law. Why inverse square law? Because the force is inversely proportional to the square of the separation between the charges. Third, it depends on the medium between the charges. One more characteristic is it is central force. Coulomb's electrostatic force. What does it mean? Central means it acts along the line joining the charges. So this was all about Coulomb's law and the dielectric constant. That's all for now. Have a nice day.